If I asked you to look outside and tell me whether it's daytime, how would you know? You might say something like, well, it's light outside, or the sun is up. But if the sun is up and that makes it daytime, then where does the sun go to make it nighttime? My name is Yesenia, and I'm here to tell you that y'all need science to figure out what is nighttime. I stayed up all night to answer this question. And then it dawned on me. Okay, seriously though, the sun doesn't go anywhere. We do. See, the Earth has this imaginary line that starts at the North Pole, runs through the center of the planet, and comes out of the South Pole. We call that imaginary line an axis. And Earth spins around its axis once every 24 hours. And we call that a day. Now you might hear me say day more than once in this video. And when I say day, I mean one Earth day, 24 hours. And that's not to be confused with daytime and nighttime. So while the sun looks like it's making a journey from east to west across our sky, it's actually us on the Earth's surface turning at about 1,000 miles an hour. So what is nighttime? Well, because of that rotation, we face the sun for about 12 hours a day. And so we call that daytime. And then the 12 hours that we face away from the sun, we call that nighttime. So the sun isn't actually moving or going anywhere. We are just turning in a circle and facing the sun or facing away from the sun. So why do I say about 12? Well, that's because the length of day and night can change. Occasionally, the Earth's orbit comes into play, and it can extend nighttime or shorten it in an area. Remember that imaginary line? Well, the axis of Earth is actually tilted at about 23.5 degrees. If that tilt was closer to zero, then our days would be exactly 12 hours each. But those 23.5 degrees really do a number on some places like the Arctic Circle. Around September 23rd, Earth's orbit makes it so that places like the North Pole get a 6-month night.
What's up, y'all? It's Editor Yesenia. I don't really think I did a good explanation there, so I'm here hopefully to shed a little bit more light on the situation. So if you look at the globe that says autumn, it's kind of hard to see it, but let's look at the globe that says winter. Assume that you're in the Arctic Circle, which is in the really upper part of the Earth. If you're deep enough in that circle, because of the angle of the axis, it might be that the Earth will revolve, but that place that you're in will not leave the shadow of the Earth. You don't have to worry about that in places like New York, but in places like Norway, they do. And that's why they get 6 months of darkness from September to March. Hopefully that helps.
The sun doesn't come back up until March 23rd. Imagine having to go to school or the playground at night. So what about other planets? We Earthlings get about 12 hours of nighttime, but do other planets experience nighttime like we do? Well, we said that daytime and nighttime are really determined by a planet spinning on its axis and how long that planet faces the sun and faces away from the sun. Every planet has an imaginary line, an axis that it rotates around, but other things like its rotation speed, how long it takes for the planet to spin in one complete circle, and its angle of axis, its tilt, will affect how long that planet gets daytime and nighttime. So I'm not going to get into each of the planets in this video, but I will point out some of the more interesting ones. Like Jupiter, its rotation speed is so quick that 1 day on Jupiter is the equivalent of 9 Earth hours. That means you get about 4.5 hours of night versus our 12 hours. On the other hand, Venus spins so slow that 1 day-night cycle on Venus is about 243 Earth days. That's right, you heard me correctly. Catch up on all your sleep on wonderful Venus, where 1 night is 121 Earth days long. So what about angle of axis? Remember our axis was at 23 degrees, so it kind of tilts a little bit this way. Well, the tilt on Uranus is a whole 98 degrees, this thing spins on its side and it takes 84 Earth years to travel all the way around the sun. And because it rotates on its side, that means that one side of Uranus has nighttime for 42 Earth years before it rotates completely to its other side and faces towards the sun for another 42 years. Pluto is interesting because it spins slow enough on its axis that you're looking at about 3 days of nighttime on Pluto. But ponder this. Pluto is about 40 times further away from the sun than we are. So, is the sun even bright enough for you to get a difference in daytime and nighttime? I'll let you do some more investigating about that on your own. And that is a perfect segue into the final question that I would like for us to explore. How do you know when it's bedtime in space? Well, we've established up to this point that daytime and nighttime are established by a planet spinning around on its axis. If you're in space, you're not really on a planet. You don't have an axis that you rotate around to face the sun. So what that means is there is no daytime or nighttime. You don't have to go to bed ever. So what have we learned? We learned that night is relative. You have to stand on the surface of a planet as it spins around its axis and faces away from the sun to experience nighttime. We learned that other planets have nighttimes like we do, but they're affected by things like rotation speed around an axis or the angle of tilt on an axis. And we learned that there is no daytime or nighttime in space. So if you don't want a bedtime, traveling into space is the way to achieve it. Thanks for joining me for another episode of Y'all Need Science, and I'll catch you next time.